Hi everyone, good afternoon. In the US it's already noon by now, afternoon. My name is Shir Meir. I'm the data science group manager at Intuit. I'm going to talk to you today about, is there an echo in this mic? It's okay? Okay, just me, sorry. I'm going to talk to you today a little bit about how we serve document understanding at scale for millions of customers while continuously optimizing and updating our models to provide the best accuracy in a very, very high scale. I think, as you all know, the world is going through a big transformation with generative AI coming to place. And a lot of our learnings, I think, can be applicable broadly to many, many tasks. Special thanks to Jorim Chala, our principal data scientist, who helped me work on these slides. To give you a little bit of background about, about where I'm coming from. I like to work at places that bring positive impact into the world. So I started working in two Israeli startups, Takadu and Bluevine. Takadu uses algorithms and statistical modeling to save water to the world. Bluevine helps small businesses prosper. And then I wanted to make even more impact, so I moved to Intuit to work at a larger scales with over 100 million customers and a lot of very interesting and high-scale data. Then I transitioned into a leadership role. I worked at Intuit Israel for 5 years, and 2 years ago I relocated with my family to the Bay Area. And today I'm on a vacation in Israel and came here to share a little bit about what we're doing with my team in the US. Right now I lead a group of 28 data scientists and machine learning engineers, all focused in providing the best document understanding experiences to our customers at Intuit, which are small businesses and consumers trying to lead their financial lives. In addition, I was always very curious about the AI and data science community in Israel and in the world, so I co-founded the PyData Tel Aviv meetups. I spoke in multiple international conferences. I had a podcast named Unsupervised about data science in Israel, and I started the WEEDS Tel Aviv conference. Okay, so when I moved to the US, I learned that filing your taxes is a big deal. If you don't know, everyone in the US needs to file their taxes. Anyone knows what is this form? W-2, right? That's the American equivalent to 106 form. It states all your taxes, the wages, the benefits that you received from your employers. The system is different than in Israel. You need to actively prepare your taxes every year. You can go to an accountant and you can go to a software like TurboTax, the software that Intuit develops, one of our main products. So, how long do you think it will manually take you to enter the data from this form for tax filing? Think about going through each and every field and manually typing it into some tax preparation software. So think about it. I checked at Google, and because there are about 20 fields in this form, it should take between 3 to 20 minutes per form. Now think about it, that each household would have 3 to 20 minutes per form. You can have between 5 to 10 different forms per household. 168 million households in the US. It is roughly 9 million days of manually entering data for tax filing. So much fun. And what is the probability of making an error when manually entering data? So if we take a rough, a very conservative 1% error per field, it could be around 80% chance that you will make an error, at least one error when manually entering all of this data. If you take a more realistic 3% error per field, it's almost 50% that you will make an error. And trust me, you do not want to make any errors with the IRS. So how can we make sure there are no errors and no wasted times for millions of customers? Ta-da! AI to the rescue. This is what we do. We build reusable AI services to enable our customers to never enter data. And we do it across Intuit products, for TurboTax, as mentioned, for Credit Karma, QuickBooks, MailChimp, who serves small businesses and consumers. So how does it look like? Basically, you have an image of some document. It could be a tax form, it could be bill, receipt, bank statement, whatever, financial document, or even other document, depends on the task you're trying to achieve. The core tasks that we first need to solve for document understanding are classification and extraction. In classification, you want to identify the document type. This should help you in categorizing, arranging the data, as well as figuring out what extraction solution would be best to use. Also, what is the output schema to be used in the product. And then extraction would take the information from the form and bring it in a structured format that the product can use. So how would you solve it? Think about it. Before we dive into that, let's look at the brief history of the document understanding space, which is actually the brief history of all of the AI space, if you think about it. So, as we all know, in 2017, something really big happened. Google Brain introduces transformers. Attention is all you need. And for the first time, there was a mechanism that allows different input elements to really attend to one another, unidirectionally or bidirectionally. Then we had BERT, encoders, that demonstrated that pre-training on large-scale data yields a model that can be fine-tuned to be state-of-the-art on multiple NLP tasks. Then we had multimodal transformers that leverage both the text and the layout information to provide better document understanding. Then we had vision encoders that, in addition to layout, also leverage the image itself by using encoders such as VIT to create embedding for the image. Then, we had generative models and LLMs and multimodal LLMs. So how can we leverage all of this goodness to create the best document understanding? So let's talk a little bit about classification. Classification sounds like a simpler task, and it is a bit simpler, but you really have to get it right so the downstream task will work well. So in the non-generative AI era, just before generative models started taking place, we did classification in these kind of technologies. One was things like CNN, using things like ImageNet that is trained on multiple images from the web, then doing some fine-tuning on a public document data set, and then leveraging our Intuit customer data and fine-tuning on our own tax documents. So that was one option, basically using an image model. The other things that, the other type of classifier we had was a text classifier. Basically, we took the image, we ran it through third-party OCR, and then did the TF-IDF to the different text output and applied logistic regression. Very simple, all of this part, but requires that OCR part. And OCR, for those of you who are not familiar, is optical character recognition. It can be done through open source packages, and it like a Tesseract or a free OCR or Pedal, and it could also be done by a third-party service like Google or AWS Textract. So each of these options has their advantages and disadvantages. You know, here you need a heavier model, here you have the OCR dependency. Each has their cost and latency considerations and also limitations. For example, how easy it is to add more classes to that classifier. And then the generative AI started coming together, and we started experimenting with models like Donut. Donut is an OCR-free document understanding transformer. So basically, the architecture, very roughly, is transformer encoder that processes the image, create the image representation, and then a transformer decoder that can be used in multiple ways, either for classification, question answering, parsing, so basically extraction. And for example, you can use this kind of model for classification. And leveraging those generative models help us get better accuracy as well as ability to extend the models to new document types much more easily. So let's talk a little bit about extraction, which is a little bit more complicated because you have a lot of inputs and they have multiple schemas that needs to adapt it for the product. So in the non-generative AI era, we had encoders. And what we did with encoders was basically approaching extraction as a token classification problem, named entity recognition, basically. So you had the model, then you call the OCR that provides the text from the image. The OCR can also provide you the layout information, for example, the bounding boxes of the text in the image. Then we went and worked with human labelers that manually labeled the data for us. For each document like this, they created key value pair according to the predefined schema the product needs to get. Then there was this heavy pre-processing stage where you needed to take the OCR and take the ground truth and create something that the encoder can work with for training. So basically mapping from this and this to this, when all of the OCR text, each of it gets a label of what its role is in the document. For example, 2016, that's the tax year. And this is how you train the encoder to basically, for each of the output words, say what is the role of that word in the document. So from the encoder, you get that classification for each of those words. And then you need to do another post-processing stage of taking that and mapping it into the key value pairs as you want to receive in the product. So as you can see, this is a tedious task. Sorry. This is a highly specialized approach. It can require one model or even multiple models to cover for each document type. And one of the biggest challenges we had with it was that we had a limitation in the annotation of the data. Because, for example, if a numeric value repeated a few times in a form in different fields, you cannot do the annotation well, because now different values need to get different, the same values need to get a different label. So the encoder cannot learn well what to predict for this piece of text. So then generative AI came to place and simplified the process immensely, because then we can just input the OCR text as is, all the OCR plus the image, if you want to do multi-model generative models, and get the output in the format you wanted. There's no annotation limitation, because the input is just the OCR text itself, and the label data, the structured OCR as the label, and the generative model, the encoder-decoder structure, learn to process the text and provide it in the schema you want. So this was a much more general approach. We saw that in this way, one model can cover multiple forms at the same time. And there's much less data processing and no annotation limitations. So to summarize this part, in non-generative models, we had multiple specialized models, fair form, we had limitation in annotation. We have problem that if the OCR has an error, this would propagate to the output. There's no way to correct for those errors. It took us about 5 weeks to train a model and 1,500 lines of code just for data processing. In generative AI, we can use one model to cover many forms. We can extract all the entities. We didn't have annotation limitation. We can correct for OCR errors because the model generates new text. It not just uses the text that it's got as input. We have multitask learning. We can do both classification and extraction with the same encoder, decoder. It takes us only 1 or 2 weeks to train a model and only 20 lines of data processing. It does require some optimization to meet production SLAs and costs, but it provides a better accuracy. So the last big problem that we have in document understanding, and I guess we also have it across in different AI tasks, is how to scale better for new forms of data, or how to quickly extract information from any new document with very high accuracy. Because each year there are new forms, new documents we want to process, and we want to cover all of them with very high accuracy for our customers, and we want to do that quickly. So then LLMs came into place. If before we talked about generative models in a smaller scale, like T5 or Donut, then comes the LLMs. LLMs can be 100x larger than the state-of-the-art document understanding models. They're trained on large web-scale data and can adapt to many tasks more easily. And they're trained to be able to follow natural language instruction. So how can we adapt multimodal LLMs for document understanding? We provide the instruction like extract all fields from this document. Of course, we do a lot more prompt optimization to get it right. We provide the OCR. We provide the image embedding. We can use the VIT architecture as visual encoder to project the image embedding as an input to the LLM. And then we can do either fine-tuning of our own LLM or in-context learning if we find that useful enough. We have a new world opening up in front of us. And the idea is that because it is much bigger and was trained on large-scale data, it enables us to quickly learn new form with a smaller data set, with smaller fine-tuning, or even with no fine-tuning at all, just in-context learning. So as we transition from small generative models to large language models, we see that the smaller generative models may be easier to deploy and scale, more inference efficient, and hallucinate less. The large language models are more powerful and flexible to adapt to multiple tasks by changing the prompts or instruction. It can learn in context without fine-tuning, as we mentioned, and could also be used, if they are very accurate, to generate labels or weak labels to speed up the labeling process. So to sum it up, let's talk about how we bring all this to production and how we actually keep our services that serve millions of customers every day up to date in the most accurate way. So first of all, we saw that usually one model cannot rule them all. So we have an orchestration service between multiple models and technologies. We keep on leveraging the evolution of AI and generative AI to achieve better accuracy, more scalability, and efficiency, as we saw. And what allows us to keep on leveraging the advancement in a streamlined manner, it is mainly the robust evaluation pipeline that we build, the golden data set, the standard metrics. Those things allow us to compare among different technologies in an apples-to-apples way. We also have ability to evaluate each model separately, as well as the whole service, working together while orchestrating between the different models. We also have a very robust monitoring in place, operational monitoring with Wavefront, as well as feedback loop, where we collect the user feedback, the raw user feedback, and measure the performance according to that, see if there's any deterioration over time. And we also have training pipelines to allow us to retrain the models easily on fresh data all the time. Thank you. The question was, did you get the 0 errors as expected? Well, I don't think you can really reach 0 errors in machine learning, but we're getting closer. Thank you. Yes?
How did you deal with the hallucination problem in such rates so high?
That's a great question, and we did sorry. How did we handle hallucinations when we are required to deliver with such high accuracy? That's a wonderful question, and I think with the generative AI revolution, we all learned about the hallucination problem and how it comes into place. And yes, we are seeing hallucinations. I think there are multiple things that we are doing. One of them is using the fact that we are doing OCR, so you can do an exact match between the OCR input and the output from the model to see that you're not, adding values that were not there in the input. Yes?
Is it better for a RAG application to use small language models than large language models? It's not the big part of the RAG application. 90% is just to bring document itself.
I think I cannot answer this question. First of all, we're not using RAG here, and secondly, I think the scale of the model depends on the complexity of the task you're trying to achieve, and not specifically if you're using RAG or not. Last question, yes?
You mentioned in-context learning and some fine-tune, where you allowed to use real user data, or you experiment with some synthetic data just for those tasks?
That's a great question. There are issues with training LLMs. Sorry, I keep on forgetting. The question was, are we allowed to fine-tune the LLMs with really customer data? And the answer is that there are limitations because we don't want to teach the LLM, personal user data. So we are working closely with our security and legal teams to find ways to do it in a secured manner by different de-identification standards. No, not fully synthetic data. Yes. Thank you.